Alright everybody, welcome to a video on the notions of inductive and epistemic probability. In the previous two videos, we looked at deductive logic, in particular propositional logic, and we went through how to employ truth tables to assess the validity of various argument patterns. Today we're going to look a bit more closely at inductive logic. That is, we're going to shift the standard that we're applying to judge the quality of inferences from validity, which remember was the standard in the case of deductive logic, to inductive strength. Alright, so here's the outline for the videos for today. So the first video, we're going to try to get clear on the notions of inductive probability and epistemic probability. And in the second lecture, we're going to look at two problems that confront anyone who wants to develop a rigorous inductive logic. Okay, so first let's ask ourselves, why do we need inductive logic? Right? There's a sense in which deductive logic was risk-free. Right? A valid argument, deductively, is one in which if the premises are true, the conclusion has to be true as a matter of logic. So the truth of the premises guarantees the truth of the conclusion. Anytime an argument is invalid, it's inherently risky. Right? The premises of an invalid argument do not guarantee the truth of the conclusion. So why should we settle for anything less than validity in our arguments? Well, one reason is that validity is often too high a standard. For example, there's plausibly no valid argument from my current set of knowledge to conclusions about what will happen tomorrow. And yet, science, for example, is in the business of making predictions from our current state of knowledge to things that are going to happen in the future. For example, that the sun is going to come up tomorrow, or that, if I drop a pen tomorrow, it's still going to fall to the ground, just like it has in the past. Right? So we often want to make arguments that it seems like are not going to be valid arguments, but still have some merit to them, right? And furthermore, not all invalid arguments are of equal merit or lack of merit, right? That is, not all invalid arguments are equally risky. And we want to have a way of assessing how risky an argument is, and inductive logic is going to give us a way of assessing the riskiness of arguments. So let's look at a few examples here of arguments. So these are examples of invalid arguments. There are different quantities of risk. So we had this argument. So one premise argument, Tokyo is a city in Japan. Conclusion, Fido is a dog. I said this is a pretty worthless argument because the premise really doesn't tell us anything about the conclusion. It has nothing to do with the conclusion. So this is an example of an invalid argument that's highly risky and is pretty much really worthless. Here's a somewhat better invalid argument. Right? Two premises. First, more than 95% of Pittsburghers are Steelers fans. Second premise, Jane is a Pittsburgher. Conclusion, Jane is a Steelers fan. Right? Again, this argument is also invalid, and yet we want to recognize that the inference involved in this argument is really of a different quality than the inference that was involved in the last argument. Right? This is a somewhat better argument. And the notion we're going to bring in to capture this is the notion of inductive probability. We're going to define it thus. The inductive probability of an argument is its degree of inductive strength. Right? That is to say, inductive probability is a measure of how strong the evidential link is between an argument's premises and its conclusion. Right? You can note that the strongest possible evidential link between an argument's premises and its conclusion would be deductive validity. Right? That's when an argument's premises logically entail its conclusion. It's the strongest sort of evidential link you could have. But short of that, there's various degrees of inductive strength or inductive probability that we should distinguish. Okay, so here's a few things we should note about inductive probability. First, note that like validity, inductive probability is a property of arguments. Right? It's not a property of individual statements or objects in the world. It's a property of arguments. Right? So we have to say that a whole argument has a certain level of inductive probability. Note secondly, and in this case, unlike validity, inductive probability comes in degrees. Right? you can have more or less inductive probability. And finally, note that inductive probability is not directly concerned with the plausibility of an argument's premises and conclusion, right? Rather, it's concerned with how probable the conclusion of the argument is conditional upon or given the truth of the premises. So let's look at a couple examples to make this notion a little clearer. So here's an example of an inductively strong argument. That is an argument that has high inductive probability. So it has one premise. There's a man in Cleveland who is 999 years old and in excellent health. Conclusion, some man will live to be 1,000 years old. This is a modification of an argument in the Skirm's text. So we say that this argument has high inductive probability because the conclusion is likely given the premise. Even though in this case, note that both the conclusion and the premise are wildly implausible, right? It's wildly implausible that any man alive today is going to live to be 1,000 years old, right? Or that there is, in fact, right now, currently, a man who's 999 years old in Cleveland. So we have a very implausible premise, a very implausible conclusion. But the argument nonetheless has high inductive probability because the conclusion is likely given the premise, right? If the premise were true, then the conclusion would be very probable, very plausible. Well, let's look at another example. So here again, a one premise argument. There's a man in Cleveland who's 999 years old and in excellent health. Conclusion, no man will live to be 1,000 years old. Now note that in this argument, we have the same premise as we had in the last argument, but now we've replaced the conclusion with something that's actually much more plausible, right? It's much more plausible that no man is going to live to be 1,000 years old than that anyone living today is going to live to be 1,000 years old, right? So we actually have an argument now that has a much more plausible conclusion to it. And yet, this argument actually has fairly low inductive probability because there's the evidential link between the premise and the conclusion is very different than in the first argument, right? If the premise is true, right, that is, if there really is a man in Cleveland who's 999 years old and in excellent health, then it's actually very likely that, or at least somewhat likely, that there is going to be someone who lives to be 1,000 years old, namely this man in Cleveland, right, has a good shot at making it to 1,000. So the conclusion of this argument, then, that no one will live to be 1,000 years old, would be implausible, given the truth of the premise here, right? So what we want to highlight with these examples is that what inductive probability is about is the evidential link between the premises and conclusion. It's not about the intrinsic plausibility of the premises and the conclusion looked at individually. Okay, now we want to distinguish the notion of inductive probability from the notion of epistemic probability. Now, as I said before, inductive probability is a property of arguments. But we also often speak of the probability of statements. So here's a few examples. I suppose I have a coin I'm going to flip. I might consider the statement that the coin will land heads, right? And I assign some probability to that statement. Right? Or the proposition that the coronavirus lockdown will end by summer, right? That's a statement that I could assign some probability to. Or DreamWorks will produce another Shrek film, right? That's a statement, again, that one might try to assign some probability to. Now we're going to refer to the probability of an individual statement as its epistemic probability, in contrast to the inductive probability of an argument. So epistemic probability, then, is kind of like truth or falsehood, in the sense that it's a property of statements, right? We assign truth values, like truth and falsehood, to individual statements. So too, we're going to assign individual statements epistemic probabilities. But note that, unlike truth and falsehood, the epistemic probability of a statement generally varies from individual to individual, right? So a statement like, this coin will land heads, that's just true or false in itself, right? We don't have to specify an individual and say, oh, this is true for them, or true, not true for this other person. Epistemic probability, by contrast, that we do have to specify an individual when we're specifying the epistemic probability of a statement, because statements can be probable given one individual sets of information or knowledge or evidence that they have access to, but have a different degree of probability relative to somebody else's knowledge or information or evidence that they have access to. So let's look at an example to see this. So suppose that I know nothing about a given coin, right? If it's a two-sided coin, maybe I know enough that it's a two-sided coin, has a head side and a tail side, and I think we're going to flip it, right? But I don't know much more than that. I've never seen it flip before. My epistemic probability for the statement that the coin will land heads next time it's flipped might well be pretty modest, right? Somewhere directly in between believing that the statement's necessary and believing that it's totally impossible, right? So I might be kind of 50-50, right in the middle. Like, I don't know, heads, tails seem equally likely to me. Now suppose that instead you have seen the coin get tossed 100 times, and every time it's come up heads, right? Then for you, the epistemic probability of the statement that the coin will land heads next time is presumably much higher than it is for me, right? So I have a sort of modest epistemic probability for the statement the coin is going to land up heads because I have less information, and you have a lot more information that really points in the direction of the coin being biased towards heads. So you're going to have a much higher epistemic probability for that statement. Okay. So hopefully this captures how epistemic probability can vary from individual to individual because individuals have different sets of information that they have access to. Now let's say how epistemic probability relates to inductive probability. This is sort of a nice definition in the Skirms text that connects these two kinds of probability. So we'll say that the epistemic probability of a statement X for a person A, remember that epistemic probability is relative to an individual, so the epistemic probability of a statement X for a person A corresponds to the inductive probability of the argument that has as its premises all the statements that A knows to be true, so A's stock of information, A's evidence, A's information, and has as its conclusion statement X, the statement that we referred to epistemic probability of. Okay? So this is a way of connecting epistemic probability with inductive probability. We have the inductive probability of arguments, and we can view the epistemic probability of a particular proposition for a particular person as the inductive probability of a certain argument, namely the argument that has its premises that agent's information set, and that has as its conclusion the proposition that we're trying to assign an epistemic probability to. All right. So let's look at an example here. So suppose that I know two things. I know that Jane is from Pittsburgh and that 95% of Pittsburghers are Steelers fans, right? Then for me, the epistemic probability of Jane as a Steelers fan coincides with the inductive probability of this argument, the argument that has two premises consisting of the propositions that I know, namely that more than 95% of Pittsburghers are Steelers fans, and second, that Jane is indeed a Pittsburgher. Thus, Jane is a Steelers fan. Right? So given that I know these premises to be true, my epistemic probability for the conclusion is just whatever the inductive probability of this argument is. Now suppose that you know something different. You only know two things again, but they're two different things, right? You again know that Jane is a Pittsburgher, but you know a little less about how many Pittsburghers are Steelers fans. Let's say you only know that it's more than 50%, but not that it's more than 95%. Then for you, the epistemic probability of the proposition that Jane is a Steelers fan coincides with the inductive probability of this argument, the argument that has as its premises your information state. So premise 1, more than 50% of Pittsburghers are Steelers fans. Second premise, Jane is a Pittsburgher. Conclusion, Jane is a Steelers fan. Right? So the inductive probability of this argument is presumably going to be lower than the inductive probability of the argument we looked at previously, the one that had 95% in it. And so correspondingly, your epistemic probability for the statement that Jane is a Steelers fan is going to be correspondingly lower than my epistemic probability of the statement that Jane is a Steelers fan. Okay, so now we've gone over these two basic notions of inductive probability and epistemic probability and seen how they relate to one another. And these will come up in our next video again as we discuss two problems for developing any sort of rigorous inductive logic. So let's turn to that video next, and before you do so, complete the participation poll for this video. All right, thanks guys.